Hello, everyone. My name is Janine Donnelly. I'm the manager of webinars for IBM Systems Magazine. And on behalf of IBM Systems Magazine, I'd like to welcome you to our presentation. We will be holding a Q&A session at the end of the webinar. You may ask a question at any time during the event by entering it into the Q&A panel. If you experience technical difficulties during the webinar, please use the Q&A panel to alert us, and someone will assist you. You may download a PDF version of the slide deck by clicking on the drop-down menu labeled Event Resources, and you'll find that on the left side of your screen. You can download those right from the platform without being disconnected from the webinar. Today's webinar, RMF SMF Analysis, Get Ahead of the Curve with Statistical Analysis, is sponsored by IntelliMagic. I'd now like to introduce you to our first speaker for today, Brent Phillips, Managing Director of IntelliMagic in the Americas. Brent, you now have the floor.
Great. Thank you, Janine. Thank you, everybody, for joining us on this webinar today. I think it's an interesting topic. We had a very good registration level for this particular topic. My name is Brent Phillips. I'm the Managing Director, as Janine said. I've been with IntelliMagic for a little over 13 years now. With me is Dr. Gilbert Houtekamer, as we would say in the U.S. He's Dutch. The pronunciation of his name is Gilbert, so if you hear me say that, I'll give you a little bit of background there. But Gilbert is, of course, the CEO and co-founder of IntelliMagic. Beyond that, he's also the primary architect of our analytics solution for the ZOS environment called IntelliMagic Vision, which is the context for this discussion today. He's also a winner of the Computer Measurement Group's prestigious A.A. Michelson Award for lifetime contribution to the performance and capacity profession. And he's also got a PhD in MVS I/O subsystems, the only person I know that does that. So a lot of depth on many different areas of the mainframe now, and he'll be presenting the core elements of our webinar today. So we've split this into three different sections. I'll talk first about what we mean about getting ahead of the curve, why and how. And then Gilbert will go through 7 different use cases for machine intelligence on the ZOS data, particularly the RMF and SMF data is what we're talking about. And then we'll wrap it up with a very brief session on how you can get started in these concepts, these use cases that we're discussing today. So first, let's just talk about what do we mean by this RMF and SMF analysis curve. How do you get ahead of the curve? Obviously, if you've been working in performance for a long time, you realize that the curve can be pretty sharp these days in when metrics jump up for any particular issue that occurs. There's a lot of redundancy and parallelism, and ZOS masks problems pretty well until it really can't handle things anymore. Then the service degrades rapidly after that point. Being able to get some advanced indication of that is very useful for avoiding some of the critical production problems that cause a lot of stress. I like this picture a lot that's on the screen today. This particular viewpoint, if you're on the guardrail with any forward momentum at this point and approaching a curve, it's pretty difficult. You're already in a bad spot, obviously. I mean, you want to be on the other side of that yellow line there. Just bumping up against the dashboard the guardrail is hard enough on your vehicle. But if you're at this point, you're probably going to go over the edge, right? So what we're talking about is being able to get better indicators ahead of time to understand where you're at and how you can adjust to avoid getting in this kind of a painful position. I mean, when you're actually on a road like this, there's signs of an upcoming curve 100 feet before the curve occurs. You have some blinders on and you're only able to see a few feet in front of you at a time. It's hard to make the changes that you need to make to navigate these kind of curves safely and efficiently. And that's really the role that we're talking about for this kind of a mathematical analysis on the data. to be able to give that kind of a warning ahead of time and deal with it. So here's a few top indicators that you are staying safely inside the rails, or really maybe inside that yellow line, as you encounter these various curves in the operation of your ZOS environment. The first one is that you most often see these performance problems ahead of time and can address the issues to be able to safely navigate the curve. So you can rate yourself as we go through these. You are ahead of the curve if you can do that. Problem resolution is another topic. If you can frequently understand what's going on without undue stress and with a little amount of time, by navigating through the data and understanding what's changed and what is out of range, acceptable range, and so on, you're well within the curve as well in most cases. Understanding things from the application perspective is also important. Being able to identify automatically as soon as significant change has occurred in the applications that are using the shared underlying ZOS infrastructure resources is an important capability to be able to stay ahead of the curve. And then, of course, forecasting as a topic, being able to understand how the workloads on an application basis are growing, how is the capacity and the headroom that you have in various elements of the ZOS infrastructure capacity. Being able to automatically update those kind of forecasts is an important capability here. Why are these four things so difficult to handle? Most of you probably weren't able to say yes on all four of those kind of items. Well, of course, there's a lot of data to deal with. I like to talk about how the ZOS platform, out of all the platforms in your data center, it produces the richest operations data. And the richer the data, the smarter the analytics can be if you have the right algorithms to analyze that. So that's a good thing if you're using smart algorithms to assess and score and rate the data. But if you're not, it's a lot to get your arms around if you're using more manual approaches to just reporting on the data and eyeballing a lot of static reports, for example. There's a lot more complexity than there used to be in the environment as well, whether it's new capabilities of encryption, for example, or compression, or cross-platform communication methodologies that are going on. There's a lot of different elements within the infrastructure itself. And of course, that's one reason why there's so much data. Everything is instrumented, and there's just a lot to instrument, and it's continuing to grow in complexity, as well as size and scope, as the diagram on the right side says, the Z14 with 170-way processors and so on and so forth. That will continue to grow. At the same time, of course, our workloads are more dynamic than they used to be. People these days using their mobile devices wherever they're at to check balances and whatnot that drive transactions on the back end. It makes for less predictability in the workloads. Most sites are still using products to report on this RMF and SMF data that were architected decades ago. And again, producing a catalog of static reports, whether that's SAS and MXG or some other product that will produce these static reports that one of the deep experts for any particular area of the infrastructure has to eyeball and try to determine, is this different? Is it out of range? How does this correlate with these other metrics? Looking at things side by side, maybe doing some report writing if you want to see other variables on it. It's pretty difficult to understand using those kind of processes based on that environment. While at the same time, the number of experts have been dramatically reduced, various headcount reduction initiatives at organizations to try to streamline things, or the skills gap is obviously playing a part in here. But it's just a lot to get your arms around. We do analysis services and health checks for customers. One recent engagement that we did for a large organization, they had over 8.5 billion different metric values for a 30-day period. And especially as consultants coming in from the outside that are not familiar right away with the environment, I mean, that's just a lot to get your hands around. And the point is we just need better technology to help us do that, to assess and rate the data. And it's really about this issue of interpretation. We used to say if you can't measure it, you can't manage it. Our problem is not instrumentation. There's plenty of measurements available. The problem is really what do they mean for performance and capacity? Do they represent good and safe values for our workloads on our particular infrastructure, or do they represent risk and cost inefficiency? That's the intelligence that we need in order to properly manage the infrastructure. So we talk about black box analysis as one statistical approach for understanding what's going on, and this is what most people in the industry are talking about with some of the newer analytics solutions that are available there. The advantage is you don't really need prior knowledge about the environment or the platform. You can say it's platform agnostic. You can feed it some metrics and start running some of these statistical analysis on the records to detect relative changes in the metric according to the baseline. And so we'll talk about some examples on this later on. But it's important also to point out that this approach, while quick to implement, doesn't really provide true intelligence about root causes or give you predictions. It's mostly about symptoms of problems, not root causes, and doesn't tell you why it's happening. It can tell you that something has changed, which is important to be able to find out about that as soon as possible. So we also talk about white box analysis, and we've been working in this particular area for well over a decade now. And this gives you visibility and understanding of what's going on in the infrastructure itself built into the analysis. We call this availability intelligence because it's deriving intelligence out of the data for the risks to availability from the infrastructure perspective for particular applications that you're running. It requires a knowledge of what the ZOS metrics are and what they mean, and infrastructure expertise to be able to say, is this a good value or a risky value for this part of the infrastructure? It can detect absolute issue violations. So there is an absolute truth about what different components within the infrastructure are capable of handling. There is best practices that represent good and bad. That's why we have all these IBM Red Books, for example. And being able to assess the metrics in this context and score them or rate them for compliance with those best practices and infrastructure capabilities gives you a deeper level of analysis. So this can derive true intelligence that's predictive and prescriptive. Both of these are compatible means, and we're using both, and we're talking about both of these kind of capabilities in the use case section today. My final point before turning it over to Gilbert will be talking about basically the jobs. I mean, everybody knows this machine intelligence topic or AI. There's forecasts for dramatic changes in the job market. How does that relate to ZOS performance and capacity? Well, this picture is obviously portraying a painful situation if you're trying to get somewhere fast. This is not the way it's supposed to be, getting the cart ahead of the horse. And while many jobs will be replaced, it's a little bit different for ZOS performance and capacity from my perspective, at least, because the jobs have already been reduced before the modernized technology was implemented. So the environments have grown, the complexity has grown, as we talked about, and at the same time, the technology to understand what the data means has, in many cases, for many shops, not been modernized yet. We haven't really leveraged the computer to be able to catch up with the job requirements based on the already reduced headcount. So that's what we're addressing today in the use cases. And before we jump over to Gilbert, we've got a poll just to ask how much interpretation do you currently use in your shop to get a little feedback, and then we'll share the results with you. So select one of these four answers. If if the humans are always required to interpret look at the reports and interpret what they mean, what the RMF and SMF metric values mean, select A. Minimal automation, if you're doing machine interpretation for a few of the metrics, would be B. Medium interpretation, if you have many different infrastructure areas with some significant metrics, would be C. And if you feel you've done pretty much everything that you ought to do regarding using the power of the computer to automatically assess and rate the metrics and identify what deserves the human analyst's attention, then select D. Give that a second to let everybody finish.
Okay, Brent, I'm going to go ahead and send these results out to the audience.
Okay, great. So A and B is pretty close there. Most sites are at early stages. There has been, we know from some of our customers using some more manual approaches and recoding things, that some ratings, so for certain kinds of metrics. But by and large, I mean, this shows what our experience is talking to a lot of different shops that we talk to around the country, that there is room for improvement in using the power of the machine to help the human analysts. Okay, so we'll go on from here and jump into the use cases at this time. I'll turn it over to you, Gilbert, and have you take us through those.
Okay, well, thank you, Brent, for the introduction, and thank you, everybody, for dialing in. So what I would like to talk about is the use cases of the statistical capabilities that our product provides, and give you a bit of context. So, like Brent says, we have been active in the space of intelligently looking at SMF and RMF data for over a decade. So we talk to a lot of customers, and those customers have questions. Typically, one of the first questions they have is they would like to know what's new today. Of course, many of you work for large IT organizations, and of course, all your applications people tell you when they do something new, but sometimes they forget, and then you'd like to know about it, and you'd like to know about it as soon as possible. But the other thing is, well, sometimes you don't know it in time, and then the phone will ring, and then you'd like to know what's happening. You'd like to have the context. Of course, it would be better if the issues would not come to you by phone, but if you would see them coming, if you would be able to identify risks to your availability or that might be of concern in the future. And this is what we've been focusing on with our products mostly, in identifying potential issues, potential availability issues early. Then when you have found a particular issue, or a particular issue is occurring from a performance perspective or an availability perspective, but typically from a performance perspective, whether it came through you by being something new or through a user complaining or an early warning, typically the first thing is you want to know, well, is this something new or has this been coming for a while? And now finally, the question is, how many days do we have? And when, say, one workload's growing, or when a storage scope fills up, or a 10 provision pool fills up. In all of these cases, like Brent says, the lack of data is not the issue for a mainframe person. The issue is to identify the relevant metrics or the relevant events in the massive amount of SMF or RMF data. So what we have focused on with our product for the last 10, 15 years is to help you identify the things that matter in your workload. And that's what statistics are for. And in the next months and years, we'll add many more functions to help you identify things based on from a statistical perspective. So if you want to know what's new, you're looking at workload changes. And we'll talk about these in more detail later. If you want to know about things before the phone rings, it's typically a matter of being alerted about a performance degradation or a response time increase for an important transaction. Avoiding the phone ringing is being alerted or being aware of the fact that you're running out of capacity, either because of workload growth or because of misconfiguration issues in your environment. Maybe some testing was done and somebody forgot to put all the channels back online. But basic stuff that does happen and that you don't notice because ZOS is pretty good in managing resource constraints until it really exhausts all its capabilities. Of course, context is always important. If you find an issue, you want to know what's causing this, which workload, which job, which data sets are involved. So it's important to have the ability to drill down from wherever you are to the detail information. And then finally, capacity planning has been, as a discipline, is probably as old as the mainframe, and trying to predict how the workloads develop and having the historical data. So all of these issues, you can use statistics to help. Of course, you need proper data, but you can also use statistics to help. And then the question is, well, when do you want to have the alert? How early do you want to have the alert? Or how early do you want to be notified? Well, typically, like Brent says, if you're using black box methods, you're going to look at metrics that describe maybe a service level or a response time. You're looking for a change that shows that something has gone bad. So typically, you'll be notified after something went bad, when a particular metric was too high or response time was not good enough. So the alerts tend to be reactive. If you look at more at the internals of how things work, and you look at metrics that are an indication of health or potential issues, then you can be more proactive. And that's actually what we've been focusing on over the last 10 years or so, to try and identify and find issues that might impact availability. And actually our tagline, the availability intelligence, has not been invented by us. It's not something that we came up with, something that our customers came up with. They said, when we use our product, your product, we'll find that our availability actually improves. We're actually getting fewer outages for our applications. So that's the 5 situations we talked about are the 5 use cases that we'll talk about first. Detecting workload changes, which is for IT planning, for service, for cost monitoring important. This is the thing that the customers and prospects we talk about care about the most. They want to know what's different today from yesterday. Is it something that I should know about? Is it an indication of a new version or maybe a new application or a mistake? So this could be independent of saturation. Then the second one is, well, if something does go wrong, they'd like to know it as soon as possible. That's use case 2. Use case 3 is avoiding issues at all. So that's avoid service disruption. That's the availability intelligence. Mostly of interest to the IT performance staff because, of course, avoidance is always better, but it's less visible. I mean, you're going to be a bigger hero if you fix a broken system than when you prevent the system from being broken in the first place. Well, the understanding workload peaks and context use cases is useful to everybody. If you want to understand something, you want to know what's happening. And forecasting is for the capacity planning folks. So we talk about those in a board meet in a bit more detail in a minute. Then there's a second set of requirements which I've labeled use case 6 and 7, which is related to the modernization efforts that some of our customers are starting, where they would like to have a centralized dashboard, a dashboard that not only shows the data from the US, but also from network and applications and all kinds of different IT aspects. And they would like to feed that dashboard with data from, well, as many platforms as they would like to see. So this is the use case where the dashboarding software, which could be Splunk or Elastic or something like that, is not so much used to crunch all the data, but to present the data in a common view. And now finally, the analytics and cross-platform monitoring application, that's the classic use case of the Splunk product, where you have a distributed environment that has many different servers that all have their unique logs, and you want to bring those together. More and more companies are seeing that this works for them in the decentralized environment and distributed environment, and they are wondering what can we do on the mainframe with technology like this. So we'll talk about that as well. So these are the use cases, and now we'll go into a bit more detail on the individual cases. So first of all, detecting workload changes. Well, when you think about a workload change, it's important to realize that you're not talking about a real-time, what happened last 15-minute thing. You're looking at did this activity grow significantly over the last maybe day as compared to the same day last week? Or did this particular transaction, which tends to process 10,000 transactions per hour, did it consume more or less the same amount of CPU that it did last week? So you're looking at properties of the software that you're running or properties of the workload as a whole. You're not looking at is there a real-time spike that we didn't see because the stock market crashed or something. So this is about characteristics that are inherent in your repeatable workloads and in your software. Well, when we talk to our customers, we find that many of the really big corporations, or at least some of them, have developed over the years software using SAS typically, or MXG, or Mix, or a combination of those, where they built code themselves to look at important metrics, to see whether the averages are statistically different from what happened the days or the weeks or the months before. And this is proven to be a very effective method to find out whether there's a change or not, or whether there's something that's worth looking at. And again, I'd like to point out, as Brent said early on, the problem of mainframe performance analysis is not lack of data. The problem is too much data. So what we do also with this capability is go through your data. Go through the data that really matters to you, like the CPU used per service class or the CPU used for key batch jobs, and see which ones are statistically different from what has happened before. And this technique of looking for statistically significant changes can be used to anything. It can be used for CPUs, for the disk systems, or for the KICS or DB2 transactions. And this way, when there is a change, you'll be notified this is different from what we've seen in the previous periods. And then, of course, you're as a technician, you want to say, well, this is nice, but I'd like to know what's happening or what is different. So just one mouse click, you'll get the underlying data, the data that we base this chart on, and you'll see the data for a whole month in this particular view for the CPU consumption and the SIP usage for a particular service class. And if this were to be an interactive demo, you would click on one of those charts, it would magnify, it would fill up the full screen, and you could do more contextual analysis, or you could look at different metrics for the same usage thing. So again, for these workload changes, the purpose is to find out what's new, what's different from what we have been seeing recently for this particular workload. The feedback from the people we have talked to, that those customers or those installations that installed this capability, tell us it saves them a lot of CPU time or MSUs, because they were able to quickly see when something new came online or when a new version was less efficient, so that they would be able to respond before it ran for a whole month. The second use case, which is probably the one that's most advertised in the context of the real-time tooling, the Splunks and the like, is want to be alerted when the response time is out of usual range. So that's a reactive thing, and the objective would be to get the alert from the software before the phone rings, so you can hopefully do something about it before your application goes down completely. There's different approaches to this, to doing these kind of notifications. Well, one is to use thresholding, basically service level agreements, which uses a fixed or workload dependent threshold or maximum response time. Say the maximum response time for an I/O is 1 millisecond if it's a 4K block, or it's 2 milliseconds if it's a full track, stuff like that. Or you could also say, well, I don't care about what the SLA is. I just want to know what it's the same like yesterday, and if it's different, I want to be informed. So the second case, the I want to be informed if it's different, might show a chart like this. So the bands, the green and the yellow, shows what's normal for response time for this particular storage system, I think it is, yeah, storage system, during the course of the day. So typically it's like 0.6 milliseconds. And then the line shown over the bars is the actual value from today. So you can see we're pretty much on the high end of whatever happened before. So the response time is pretty high. Then, of course, the next question is, well, why? And that's a question that you always want to know. And well, in this case, it's because it's high. It would be alerted as being exceptional. So that would be a frame around it. And the context would be, well, if the response time is high, it's like we're looking at the response time, which is a bit more than usual. The first thing to ask yourself is, well, is the workload the same? Well, clearly not. The I/O activity for these storage systems is a lot higher, right? So you can see that the workload is almost twice as high as normal, and the response time is a bit higher, but still acceptable. So you're probably fine with this particular change, and hopefully they told you before that the I/O rate would go up from 5,000 to 10,000 I/Os. And hopefully this would be a planned change. The other approach is the dashboarding approach, which we have been using, where the response time might be one of the metrics you would look at. So this would be compare a dynamic metric to a particular threshold, basically not necessarily knowing what happens. Or what we've been doing more and more is you can see this dashboard, which looks at the health of a storage system, does not have one column, it has many columns. And the other columns are subcomponents or even internal metrics that help predict when things might go wrong. So like on this row, you can see one of the subcomponents being not completely healthy. It does not yet affect the overall response time we're reaching the danger zone. So this is thresholding with a bit more intelligence. Which brings us then to the solution that we like to call availability intelligence, or the objective of avoiding service disruptions, which is looking at metrics, at mainframe performance data, from the perspective of does this particular metric help or indicate a risk to the environment. If this particular metric would be out of range or in a particular range, might that indicate a potential issue to a higher response time or even potentially availability issue over time. So those metrics could be a storage system reaching the maximum bandwidth capability, or the backend response time, or workload manager not being able to meet its goals. I mean, you may still feel response time is quite okay from a user perspective, but it may not be okay according to the objectives that you have set for the workload manager. Redundancy issues or DB2 buffer space, lots of stuff. So in cases like this, what we do in our product is we look at those rules or conditions every interval. So we basically do 100 checks every day, and then tell you we apply then statistical analysis on the results. And if a particular error condition or concern happens often enough, it'll show up in a dashboard. So that's essentially how the dashboards are done. So these are 100 checks for a particular day, and then the results are summarized. And you can see in this particular one talks about workload manager rules by importance level, and you can see that this particular system is, in terms of performance index, very constrained. So workload manager is unable to meet the goals that you gave it to work. Well, if workload manager is consistently unable to meet its goals, it basically is going to be less effective. Well, you can also tell from this approach or from this white box methodology is because the concern is to a particular metric and is related to a particular rule. Not only will it identify the issue, but also will it tell you what to do about it, because we know exactly what's happening. That's another benefit of the white box method. Well, likely most of you are techies on the phone, so you'd like to know, well, it's nice, these bubbles, but I want to see what's behind it. So, of course, one mouse click and you'll get the complete chart showing the actual values of the metrics that we were concerned about. In this case, performance index consistently being 1.5 rather than less than 1, which it should be. Again, so this is an indication of something not necessarily being broken in the sense that your systems may still be responding, but your workload manager is not happy about what's going on. So the customer feedback about our methodology when we tried to get feedback, so what you do as a company, you try and get user stories. Please tell us how great our product is, and we would expect them to say your product helps us improve performance, but typically the feedback we're getting is your product helps improving availability. So that's what we find. The result is because of the data mining, because we identify interesting issues, it's easier or more focused for the performance staff to direct their attention to the areas that matter the most for performance. Well, we did quite a bit of work on making drill downs or making it possible, say, if you're looking at the storage system, to go look at a particular workload and say, well, on this box we see the I/O rate increasing, and then you provide a drill down capability to see which storage groups or which data sets are important. But our customers told us, well, it's nice that you have this capability to see the peak and to look at those peaks and drill it down or find the details on the workloads that are actually causing it. But typically our first thing would be to look at, well, is this something that's new? Is this something that has happened before? So what you can do in our product with just one mouse click, you click on this dialog which has the date on the top right hand of the slide. You click on the dialog, and then you tell it, well, I'd like to see side by side two different slides. I'd like to see the original slide, and I'd like to see what happened last week. Now, if you look at the blue spike that was visible on the right hand slide, which was the same as today, and then the other one is 1 week ago. If you compare those two, you can see the spike was there the week before as well. You can also see, by the way, that one of the other storage systems had a very different behavior. It actually got a lot better in terms of response time. So by being able to quickly go back and compare the situation with today from last week, you have a very good indication as to whether this is something that you should pursue or not. Is this something that's happening every week? Well, likely it's not going to be fixed very easily, but also on the other hand, it means if you do fix it, you're going to have an improvement going forward. That's going to have a lasting impression. That's going to help for a long time. And there's lots of more visualization stuff that we do. So, like if you look at these charts, you can click on those and see the data from the chart in tables, and you can see the hotspots really easily. So you can see which time periods show the highest workload and which time periods have the peak for particular metrics. That's just a quick and easy way to look through a chart in a more tabular form, just because different people have different preferences. We have different ways to look at the data. Forecasting is a whole discipline in itself. So those of you that work from mainframe sites, you know the processors are fairly expensive. So you guys are probably all have sophisticated methods to predict what's going to happen. From our perspective, from the Internal Magic Vision perspective, we do provide all the metrics that are helpful to make those predictions. But it's hard to guess what every installation needs or what every installation wants to use. So our focus has been so far more on our forecasting on the storage side, where workload growth can be more aggressive than on the CPU side typically. So where it's important to look at storage groups, or maybe when you're using on a modern system, when you're looking at DIMM provisioning, you want to see how quickly things go bad. On the CPU side, of course, you can do the same thing. You can look at how does the CPU consumption increase or how does the MSU consumption increase and do modeling. But I think for most installations, that tends to be well controlled. So the forecasting ID for us is partially the same as detecting workload changes. So if there is a steep growth, it's something you want to be aware of. And partially it's a long-term thing of looking at the long-term data. So this particular table shows the growth over the last 90 days. And again highlights the, in this case, storage groups that grow the quickest. This chart is just one of the very many charts, of course, you could make in terms of growth or in terms of forecasting. And our approach is to work with the customers to make the charts that they like. So basically, it's up to you what you want to see, and then we can design those charts for you. Just like with the data for the workload changes, just one mouse click and you can see the change. So in this case, you can see actually, well, really this workload did change significantly over the recent time period. Height is a lot higher, the peaks are a lot higher than they used to be. A new capability for, the old capability is essentially looking at storage group free space, and there's an equivalent capability to look at thin provision pools, which is fairly new for mainframe people to use thin provisioning. As you know, the thin provisioning is nice to have. It's really nice that you can give out more storage than you really have. But if you give out more than you really have, you also have to monitor, well, how much are people really using, and am I not hitting the limits unexpectedly, because then you wouldn't be able to allocate new data or new data sets anymore. Of course, in addition to these specific charts about growth, you can also just do a long-term chart and see what happened over the last 2 years on a day-by-day basis. That's another way of looking at the data and then potentially exporting it. On the dashboards, on the enterprise dashboards, we have worked with a couple of customers that have used or have decided that Splunk would be the enterprise dashboard of their choice, so that they would like to see the results from our product summarized in the Splunk environment. And that could look like this. So this is a dashboard that shows 6 charts with key metrics that were important for this particular environment in the Splunk product. Now, it's actually pretty simple to do because we can just export those data from the Internal Magic Vision dashboard. So you make the vision data, and then you export it into Splunk, and you get very similar charts, obviously, because it's the same data. Well, the benefit of using an enterprise dashboard like this is that because the data is processed by vision and only the results are given to Splunk, not much data is ingested into Splunk, so that's price-wise an efficient way to do things. From what we've seen in most customers, this has not been driven by the mainframe groups, but by the distributed platforms, where the mainframe is more like, would be nice to have some key metrics on the mainframe as well. Well, then finally, the last use case talks about analytics. And maybe I'd like to give a bit of a perspective about analytics and what you can expect or maybe what you cannot expect. Well, you can see this self-driving car on with the Tesla, which is kind of supposed to be a self-driving car, more or less. As you all know, a lot of money has been invested in making self-driving cars. Well, this one is obviously not self-driving, or at least it can drive itself on the highway, so it can do a very simple use case. Just think about how much money and time and engineering has been invested to make a self-driving car. Now think about how many hours it takes to train a human to drive a car. I suppose most of you are American, and in the US it takes like 8 hours, I guess, before you can get your driver's license. In Europe, maybe 30. So something that a human person can learn in a week, is taking the engineering folks a lot of time to develop. I'm not saying a self-driving car is the same thing as analyzing or looking at ZUS data. But we did talk to quite a few customers that have been filling their data lake, that have been ingesting lots and lots of data into Splunk, hoping that results would come out of it. Obviously, that's not how it works. I mean, it's nice to have all the data, but the analytics you have to provide yourself. It's just like when you install SAS, or installed SAS like 30 years ago. It didn't magically give you reporting. You still have to develop the reporting yourself. And essentially we see the same thing reoccurring. So in the 70s you had SPSS and then SAS, which took over. Now we have IBM's machine learning environment, and one of the key features is that they have integrated SPSS into the machine learning environment, which basically means it's all about statistical analysis, and the tooling is there to actually do stuff. Well, what you'll find out if you try to do things, that analytics is not there's no freebies. You need to have a detailed understanding of what's happening, and I attended a presentation by Professor Verbeeker from the analytics department in Brussels a couple of weeks ago on the 7 steps that you have to go through before you could, or when you successfully apply to predictive or prescriptive analytics. So essentially, when you want to do maybe machine learning, well, that's a bit of a dangerous term because you're just teaching the machine a statistical trick. And when I saw this list, it was remarkably similar to what we do in our product and what we've been visualizing with the wheel, which is essentially looking at a particular issue or particular ZUS area, and then design a dashboard or design look at an area, say maybe replication, a storage system replication. So then we would look at that particular area, see, well, what data do we have about storage replication? In particular, what data do we have that might predict what's going to happen? So you'd pick the data fields, you'd clean the data because the SMF data is pretty clean and well done by itself. By IBM, it's one of the probably most documented and best data sources. But still, my experience is whenever you have new data sources, whenever we look at records we haven't looked at before, we find all kind of interesting and new and unexpected stuff is happening. So it's quite a bit of work to find the data, clean the data, and transform it into a way that it can actually be used, or in a that meaningful metrics will result from a performance perspective or from an availability perspective. So that's the transformation. Then the data needs to be analyzed, which is in our availability intelligence environment, basically our rating mechanism, finding out what's good and what's bad. And then from the rules will result a particular interpretation and a particular recommendation. Of course, if you need to do this, it takes time. So one of my projects for last year has been to work with a couple of people on DB2 support for our product. And I tend to be an optimistic person, so I figured, well, how hard can it be? Well, DB2 has over 1,000 metrics in its performance and accounting data. Just going through all these metrics and finding out what's relevant is not an easy task. It's not a simple thing to do. Well, we ended up with about 75 metrics that we felt were most relevant to find out whether a particular DB2 environment is healthy. And then we're not even talking about metrics that we could look at to pick changes. So it's a lot of work to actually identify what you need to do from the from analytics perspective, from having a product or having a toolbox essentially, to having a solution that will do you any good. And in that sense, in a way, whether you use Splunk or SAS, it's the same thing. When you have the environment that is very capable, that allows you to do lots of statistical capabilities, but you'll still have to find out what you want to apply the statistics to. And we're finding that having, so if you were to use the IntelliMagic Vision data and feed that into Splunk rather than the SMF data, in terms of the steps, the cleaning, the first 5 out of the 7 steps have already been done. So you have much higher quality data essentially to look at from the analytics perspective. Obviously, once you have data into an analytics platform, you can do very sophisticated analysis. You can do things like clustering, or you can do time series analysis, or whatever you want to do. So it's not that it's not powerful. It's just that it's not easy if you need to do this as a side job to set up a complete reporting environment. So what's the benefits of using Vision to feed Splunk? Well, first of all, you can be very selective about what you process. Say if you want to process CAKE's data, you wouldn't process the individual transactions. We would do that in the Vision product, and you would get the summaries into the Splunk environment. There's less need to know about all the detailed metrics, and there's much less data going through the pipe, which is more efficient. Well, the result of the stuff that you are sending is very boring. In the end, you're sending numbers. I mean, that's the same that you would do with SMF data. Only these are just the metrics that you're interested in. So you would be much more focused than when you would have to invent all of this yourself. So the way we look at the enterprise environment, or the data lake concept and analytics, is that yes, you could of course try to do everything yourself, but why would you? It may be more efficient to build on something that already exists and that has done a lot of normalization. So that's the content, or our take on statistical analysis and RMF and SMF, and now I'm going to give it to Brent for the second poll question.
Okay, thank you, Gilbert. We'll go ahead and launch a second poll here. And in the meantime, if you have some questions you want to ask, go ahead and post those. We have numerous questions already. We won't get time for them all during this webinar, but we will respond by email to you afterwards if you post a question there. So in the meantime, we're interested in understanding which of these use cases do you think are important for your site. So we went through 7 different use cases here, and this is a select all that are top priorities or are important from your perspective. We're just looking for some feedback for your shop, whether you do this today or not to some degree. Having the computer analyze the data and present more intelligence in these 7 different areas or the different applications. If you find that would be useful to you, we'd be interested in getting your feedback. So we'll give you a couple of moments to fill that out. And then after that, I'll make a couple of comments about delivering this kind of machine intelligence that we're talking about via the cloud. And then we'll get to a couple of questions.
Okay, Brent, I think a pattern's emerging here. Should we go ahead and send these results out?
Okay, yep.
Here you go.
Okay, great. Thank you for answering those questions. Thank you, Janine. Everything has some interest. So interesting that the first 2 cases are the highest, and forecasting is maybe second. So appreciate your feedback very much on that. You can get the results, I think, in the webinar recording afterwards if you want to spend some more time on that. But let me jump to just one slide really on part 3 to help you understand how this kind of intelligence from IntelliMagic at least can be consumed. It's easier than you might think. Of course, we've spent many man-years developing these algorithms and digitizing the ZOS expert knowledge from various sources and experts so that the algorithms can read them to assess the metrics and score or rate the metrics. And we also are running this whole kinds of analytics engine on hardware. So we find that performance and capacity teams these days are already overloaded, and to have a person that needs to spend maybe half time or full time in some cases, depending on the product, maintaining the product infrastructure as opposed to analysis is not the preferred approach. So we can do all that work for you. Essentially, all you have to do is FTP the data to us on an hourly basis or daily basis. There's multiple ways to set that up. We provide the infrastructure and the people to manage it and give very easy access via a web browser to the same level of detail as if you were having it on-premise. So the solution is available still on-premise. If you can't send the data out, that's often a question that we get. However, we're doing this for some of the largest shops, even in the financial services industry today. So it's metadata about the infrastructure performance. There's no personally identifiable information in there. So it's pretty easy to get over to us, and this also enables us to do services. I mentioned the 8.5 billion metric company. We just did some services for. It's an easy way to understand the capabilities, to engage us in a low-cost engagement for that kind of thing, to assess and rate everything that IntelliMagic thinks is important for somebody to look at in your particular infrastructure. So there's numerous options there if you want to contact us about that. We'll take a couple of questions here. Gilbert, I'll route these to you. There was one about the response time for a transaction slowly degrading. So as opposed to a sudden change, how do you detect a slow boil? So that looks like a good question. Do you want to take that? Okay.
Yeah, on the slow boil, in the sense that if you're really slowly increasing the response time, the statistical change, like in the first one, will not find it. So you are not going to find it through a certain standard deviation change. You will find it through our dashboarding, which will identify that the response time is reaching absolute limits or particular components are being overloaded. So you'll typically not find it through a sudden change, but you will find it through the dashboarding.
Mm-hmm. Okay. There's a question, how does this compare to IBM ZAware? Do you have some comments on that?
Yeah, you probably have to ask IBM as well. I think ZAware, from our perspective, what we have seen, ZAware is very much a black box solution. So ZAware looks at logs and sees, well, I haven't seen this thing before, so let me tell you about it. ZAware does not have a whole lot of built-in knowledge or awareness of how things should be working, or what should be expected in a normal environment. So ZAware is mostly focused on looking at logs, syslog data, and seeing what changes do we have, or what atypical messages do we have in the syslog. And that's something that we don't look at all. So I think ZAware is I would position it as being black box analysis on system logs, while we would do more interpretation and data mining on the SMF and the RMF data in a more meaningful or more interpreted way.
Okay. Can you apply the statistics to any metric?
Yes, you can. So the way we'll be delivering this is initially through services. So we will provide the metrics that we think are the most important in our existing GUI. So you'll be able to see those in the statistics header. Our product, however, does have like 4,000 different metrics that we keep track of. So we do expect that certain customers will have requirements to track a metric that we didn't think about, and then we can just add that to the GUI with a small consulting engagement, or basically just add it to our definition file. And over time, we do expect it to have it in the GUI, so you can pick your own. But initially, it'll be through services.
Okay. There's some other interesting questions, but I think I need to turn it back over to Janine now, so we will get back to you by email if you've posted a question. Thank you for that. Janine, we're at the top of the hour, so I'll turn it back to you.
Thanks, Brent, and I just want to thank everyone for attending today's webinar. I also want to thank Brent and Gilbert for sharing their expertise with us, and let you know to watch for a follow-up email that will come out later this week, and it will contain a link to the recording of today's webinar. So that's all the time we have. Thanks again for joining us, and have a great day.